All right, now recording. And share the screen. Okay, so the calendar, 11.1 today. And actually, I'm going to do 11.1 and sneak in some of 11.2 also. It'll just make it easier for me. I decided not to wait until Thursday to give you an introduction to 11.2. So I'm going to do 11.1 and some of 11.2. That way, Thursday, finish the rest of 11.2, questions and answers, and then give you a quiz. And then the next test is Tuesday. Okay, so same rule for the next exam. You will turn in everything here, 10.1, 2, 3, and 4, which we're already finished, 11.1, 11.2. Okay, I have a 70% homework requirement. You must turn in at least 70% of the homework. Okay, that should not be that bad because I've shown you how to do a great number of them anyway. Okay. And so again, on the test day, which is now next Tuesday, a week from today on the 27th, I'll let you start off with questions up until a limit of 6 o'clock. So we're going to start as early as 5:40 and as late as 6 o'clock. I'll project it like this, but I'll also send it through Canvas announcements if that's better for some of you. And the rest of the class period, you have to do the exam, work out the problems just like we do in class. You get one formula sheet, one cheat sheet, 8.5 by 11, both sides, but no other books, notes, can't use, Peepo, computer, check something online and all that kind of stuff. Right, and you have to submit the homework at least 70%, and if you don't, I don't grade your test, right? So that's the way it was for all the exams. Okay, and I usually give about 10 questions, as you know, so I think that'll probably still be true for this one. All right, so any quick questions before I start? Okay, yeah, anybody who just joined, got you. Omar, got you. Caitlin, I got you. Nazanin, I got you. Aris. Okay, so I think we're caught up. All right, so go is 11.1 and some of 11.2, at least giving you the formulas that you need for the next exam. So next time I'll finish the rest of 11.2, questions and answers and quiz. And you can still ask questions on Tuesday just before the test. Okay, so here we go. 11.1, new derivative formula. Okay, should be fairly straightforward, I think. So on page 695, here it is. If y equals natural log of x, ln x, dy dx equals 1 over x. Okay, you can put it on your cheat sheet. If we were meeting face to face, I'd make you memorize it. But, there we are. The derivative of natural log of x, 1 over x. Okay, and of course, dy dx is one of the symbols for derivative. You can also put y prime or f prime of x, of course. Right, so derivative of natural log function, 1 over x. Okay. And in conjunction with that, we still have product rule, quotient rule, chain rule to worry about. Okay, so what they have here is correct, but I don't think you even need to look at it. We're just going to go right to the chain rule as necessary, and I'll show you how it works. All right, so big thing to put on the next cheat sheet, derivative of natural log of x is 1 over x if you need it. Maybe you don't need it, then don't put it down. Okay. 11.2, we have exponential functions, and I will at least introduce that today. That's my game plan to show you that. So you have all the formulas, all the derivatives that you need leading up to the next exam next Tuesday, okay? All right, so without further ado, we'll go right to it. Okay, so what do we have? 1 to 24, odd, and 43. Again, I'll do most of the evens. So again, my 11.1, page 700. Okay, so there's all that. 19. Okay, that goes up to 22. Sorry if it looks crooked. I have to angle it because I can't see the arm of my document camera. Then there's 23 and 24. And then the last one was 43, one word problem, I think it was. So yeah, here we are. Okay, it just says marginal. So marginal means derivative. Okay, so there we go. Okay, I do hear some background noise, so can everybody please make sure that they're muted? All right, so here we go, 11.1. I'll do the evens, the odds are just like it. So number 2, y equals 3 natural log of x. Okay, so the derivative of natural log of x is 1 over x. If you have a number in front, 3 ln x, that's the constant multiplier root. The derivative is just 3 times the derivative of ln x, 3 times 1 over x, or final answer, 3 over x. So again, I do 2, you do number 1, which is almost just like it. I do 4, you do number 3, which is almost just like it, and so on. Okay. Number 4, y equals natural log of 5x. Okay, they wrote it like this, but I put in red the parentheses because that's really how you want to think of it. It's ln of the quantity 5x. So that's going to be a chain rule, right? So if I just cover this up with my finger, the derivative is going to be 1 over that times the derivative of the inside. Okay, so I go for y prime 1 over 5x times the derivative of 5x, which is 5. And then you notice, oh, the 5's cancel out. So I just get 1 over x again. Okay. All right, now number 6, there's actually 2 ways to do it. I guess you'd say the easy way or the hard way. I'm going to do the hard way first for number 6, where you just take it as it is. F of x equals natural log of x cubed. So chain rule, right? So you're going to go 1 over whatever's behind my finger. So 1 over x cubed. Then by the chain rule times the derivative of the inside function. Derivative of x cubed is 3x squared. And then notice if I try to combine these, right? X squared on top, x cubed in the bottom. After you cancel, you have an x left over in the bottom. So 3 over x. That works. It's a little bit harder though. Here's the easier way to do it. So this problem is considered finished, but the easier way is to use properties of logs. You might remember that if you have a property of logs ln of x to an exponent, that exponent gets to come down in front. In other words, ln of x cubed is 3 ln x, which is really the same thing as my problem number 2. Okay, so it's just 3 times 1 over x or 3 over x. So you can see you get the same answer either way. This way is considered easier. In fact, some of the problems that I'm going to do later, it's way easier to get rid of that exponent, right? I don't have to fool with x cubed, x squared. Just bring the 3 down and I don't have to fiddle with it anymore. So, which means whenever I have the option of doing that trick, I'll do it. Namely, if you have ln of x to some quantity, bring that quantity down, and then it becomes a much easier derivative. Okay. Okay, problem number 8. Y equals natural log of 6x plus 1. And maybe before going on with that, you might say to yourself, can I do anything to simplify this? Ln of a sum, ln of something plus something. The answer is no, you can't do anything with this. Okay. Like you might say, can I distribute ln 6x plus ln 1? No, you're not allowed to do that. Okay, so we just take it as it is. So it is a chain rule. So ln of something. So for the derivative, which I'm writing as dy dx this time, doesn't matter which symbol you use for derivative, we just know we're taking derivative. So 1 over that whole thing, 1 over 6x plus 1, times the derivative of 6x plus 1, which is 6. Okay, and then 1 times 6 is 6. So final answer, 6 over 6x plus 1. And that's basically it. Okay, and a little reminder, no, you cannot cancel the 6 with the 6. You can't cancel once you add or subtract something unless they're exactly equal. Now, if you didn't have that plus 1 there, if it looked like this, 6 over 6x, then you can cancel the 6's. Once you start adding or subtracting something, no cancellation, unless the top and bottom are exactly the same. They are not exactly the same. So just have to leave it like that. Okay. All right. So that's the basic idea for ln x. So we'll do several more. Okay, so derivative of natural log of x, 1 over x, but we have to combine it with the product rule, quotient rule, chain rule, all of that also. Okay, number 10. So if you ever have an odd problem and you're not sure how to do it, look at the corresponding even one, right? Say, I don't know how to do 7. Look at what I did for 8, right? I don't know how to do 4. Look at what I did for, I don't know what to do for 3. Look at what we did for 4, and so on. Well, I take it back. That's assuming you have the same book as I do. I know some of you don't, but it's close. You know, whatever book you have should be somewhat close. All right, y equals ln 8x cubed minus 2x minus 2x. Okay, maybe I should talk about getting this out of the way right away, right? What's the derivative of negative 2x? Negative 2. So that's the easy part. The harder part is to differentiate ln of 8x cubed minus 2x. Okay, and again, I said differentiate. What does differentiate mean? Take the derivative. All right, so you go 1 over 8x cubed minus 2x times, by the chain rule, the derivative of the inside function. So what's the derivative of all this? 24x squared minus 2. Okay, and then just slide the 24x squared minus 2 with the 1. 1 times that is just going to be that. So final answer, 24x squared minus 2 divided by 8x cubed minus 2x minus 2. Okay. All right, number 12. S equals ln 1/4 q squared plus 1. Now, don't get thrown off by the letters. It doesn't matter if you have x, y, or s and q. They're just letters. So I can still take the derivative, which I can write this time as ds dq, right? Which tells me my variables are s and q. Rate of change of s with respect to q. All right, so 1 over, right? 1 over 1/4 q squared plus 1 times the derivative of 1/4 q squared plus 1. 2 times 1/4 is 1/2. So 1/2 q goes on top. Okay, so I could have the answer like that, but that looks too clumsy. 1/2 q over 1/4 q squared plus 1. To make it look nicer, how about multiply top and bottom by the common denominator of these two, which is 4. Okay, so multiply top and bottom by 4. So 1/2 times 4 is 2. So 2q divided by q squared plus 4. So that's a much better final answer, as you can see. Okay. All right, the next set of problems, well, I'll just show you what's going on. Starting with 13 on. Look at A and B. 13A and B, 14A and B. They are the same thing. Okay, so if you look at 13A, ln x minus 1, it's the same as 13B. We have a property of logs. Sorry. Yeah, it's going to be hard for me to point this out unless I put this down. Sorry. So maybe it's not focused. But remember, you have ln of a quotient, right? Ln of something divided by something is ln of the top minus ln of the bottom. Likewise for 14, ln of a product, ln of something times something, ln of the first plus ln of the second. Okay, for 15, okay, these are the same. ln of x squared minus 1 to the 1/3 power, you can bring the 1/3 down. Basically, what I'm saying is that A and B are the same, so I'm going to do the one that's easier. Okay, normally the easier one is the A problem. Okay, take a look at B. You'd have to go 1 over a fraction and then do the quotient rule after that. But this one, you don't have to do that. Okay, so for all these problems, you don't have to do A and B, just do the easier one. And normally the easier one is A. I'm only going to do A in every case, okay? So that's 13 through 18, I guess. Okay. Okay, so 14, A, ln x minus 1 plus ln 2x plus 1. That is way better than B. So don't even do B. All right, so y prime, 1 over x minus 1 times the derivative of x minus 1, but that's just 1, which means you don't even have to write it if you don't want to. Plus 1 over 2x plus 1 times the derivative of 2x plus 1, which is 2. And 1 times 2 is 2. So final answer, 1 over x minus 1 plus 2 over 2x plus 1. All right, 16a. Again, I'm only going to do A. B is harder. If you look at 16b, it's ln x to the 4th minus 1 cubed. So some chain rule. It's way better to bring that 3 exponent down in front. And then you have 3 ln x to the 4th minus 1, which I still have to do, but it's going to be a much easier problem. Okay. Okay, so y prime, what do I do with the 3? Just leave it. Go 1 over x to the 4th minus 1 times the derivative of x to the 4th minus 1, which is 4x cubed. Okay. So in the denominator, just leave the x to the 4th minus 1. On top, I have 3 times 1, 3 times 4x cubed, 12x cubed. So 12x cubed over x to the 4th minus 1. Okay, you don't really have to look at this. I think the last time I taught this, somebody had a question about the derivative of x cubed, and derivative of x cubed, of course, we know is 3x squared. So leave that alone. Okay, 18, same thing. The easier one to do is the one that I'm picking right here. 18a. 3 ln x minus ln x plus 1. Okay, I'll go ahead and show you B. 18b, ln x cubed over x plus 1. It's a fraction, which means it's going to be a subtraction. Ln of x cubed minus ln of x plus 1, and that 3 exponent gets to come down in front. See, that's way easier than taking it as is. You'd have to go 1 over x cubed plus 1, flip it, and then do the quotient rule. Okay, much better if you do properties of logs. 18a. Okay, in fact, the answer comes out real fast. So y prime is 3 over x, 3 times 1 over x, minus derivative ln x plus 1 is 1 over x plus 1 times the derivative of the inside, which is 1. So you don't even have to write it. That's it. Much faster than trying to do part B. Okay, so starting with 19 and 20, they give you most of the time the harder version, like 19 and 20. And we're going to simplify it before we start to make the problem much, much better. So here's how you do it. All right, 20 goes like this. S is ln t cubed t squared minus 1. This is a product, something times something. Therefore, I can write it as ln of the first plus ln of the second, ln of t cubed plus ln t squared minus 1. And even here, I can bring the 3 down in front. So 3 ln t. Not here. Once you add or subtract something, you're not allowed to. Now, if it was like this, ln of t squared, I can bring the 2 in front. But not when you add or subtract something, then you just got to leave it. All right, so I'll do this. There's no product rule like I would have to do over here if I left it as the original. All right, so S prime, 3 times 1 over t. Well, 3 times 1 over t is just 3 over t, right? And this one 1 over t squared minus 1 times the derivative of t squared minus 1, 2t. And yeah, 1 times 2t is just 2t. So final answer, 3 over t plus 2t over t squared minus 1. And you can just leave it like that. Okay, 22. Y equals natural log of 3x plus 2 over x squared minus 5 to the 1/4 power. You see how clumsy that is, but we can make it a lot better. 1/4 comes down in front. It's a coefficient. And here's a quotient, something divided by something. So leave the 1/4 alone, then bracket ln of the top, x 3x plus 2, minus ln of the bottom, x squared minus 5. Okay, so I don't have to do the 1/4. I don't have to do the quotient rule. This is way better. Okay, so dy dx, leave the 1/4 alone. What's the derivative of ln 3x plus 2? 1 over 3x plus 2 times the derivative of 3x plus 2, which is 3. Same thing here, minus 1 over x squared minus 5 times the derivative of the inside, 2x. And of course, multiplying by 1 is easy. Just slide that 3 over, slide the 2x over. So here's my final answer, 1/4 parentheses 3 over 3x plus 2 minus 2x over x squared minus 5. Okay, do the same thing for 24. So before we start, ln x squared times x to the 4th minus x plus 1. So this is a product. It's ln of something times something. Okay, in fact, we did some of that way back at the beginning of our class, right? Day 1 or 2 or something like that, property of logs. So it's ln of the first plus ln of the second, natural log of x squared plus natural log of x to the 4th minus x plus 1. Okay, now you can't do anything with this because it's a sum or difference, but you can bring that 2 down. 2 comes in front, 2 natural log of x plus ln x to the 4th minus x plus 1. Now we're good to go. All right, derivative 2 ln x is 2 times 1 over x. Well, 2 times 1 over x is just 2 over x. And the derivative of ln of something is 1 over that thing behind my thumb, and then times the derivative of that. So 1 over x to the 4th minus x plus 1 times the derivative of this, which is 4x cubed minus 1. Okay, and yeah, normally all that happens is this slides over with the 1, because when you multiply by 1, you just leave it alone. So final answer, 2 over x plus 4x cubed minus 1 over x to the 4th minus x plus 1. And there we go. All right, so I've literally done the evens. Let me check 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, I've done all the evens. You do the odds, except for 43, one word problem, mini word problem that I'll show you in a second. In fact, I'm just going to mark this off. I'll show you 43, then I'll sneak in some of 11.2. Okay, so let me do my focus thing for what I've done so far. All that. And that. 22. And 24. Okay, I've got more in this paper. I'll go ahead and show it to you, but I haven't shown you how to do it yet, but I will shortly. Okay, the one word problem, let me knock that out of the way and then I'm finished. 43. All right, so a cost function, C of X is blah, blah, blah. Find a marginal. What's marginal? Derivative. B, plug in 200 to the marginal. Okay, so there it is. And then C says something about total cost functions always increase because producing more items costs more. What then must be true of the marginal cost? Does it apply in this problem? it means it must be positive. Okay, so we'll see that. Okay, so here's the cost function. As for the marginal means derivative. So C prime, derivative 1500 is 0, it's a constant. Derivative of 200 ln 2x plus 1 is 200 times 1 over 2x plus 1 times the derivative of 2x plus 1, 2. So 200 times 2, 400. 400 over 2x plus 1. Hence the answer to A. B, they tell me to plug in 200 to the marginal. Okay, 200 here, 400 over 401. Well, it's practically 1. In fact, if you punch in a calculator, it's 0.9975, they would round that off to $1, right? What does it mean? The cost for producing the 201st item, the next item, is about $1. All right, now that diatribe that they had in C says total cost functions always increase because producing more costs more. What must be true of the marginal cost function? Does it apply in this problem? That means the marginal function should always be positive. C prime should be positive. And let's check. The derivative was 400 over 2x plus 1. That's going to be positive if x is positive. And in this kind of problem, it's going to be positive. There's no such thing as producing negative items, right? So yes, that will be true. C prime is positive if I plug in any positive quantity, as you can see here. All right, so I'm actually done with 11.1, as I said, and I'm ready to sneak in some of 11.2. Okay, so let me do my focus thing quickly on 14. Oops, sorry, 11.43, I should say. So this and this, and there we go. Okay. So again, just to make things easier next time, and so you have a head start onto what's the last section all about. So I want to at least give you all the formulas by today, so you have a whole week to prepare for it. So I am going to begin 11.2. Probably won't finish it next time, and let you ask questions, and then we have our quiz. Okay. All right, so 11.2 is on the exponential function. E to the x. So what is the derivative of e to the x? Here we are, page 703. The derivative of e to the x is itself. The derivative of e to the x is e to the x. Okay, and if you want to put that in your cheat sheet, you may. Again, if we were meeting face to face, I'd make you memorize it. But hey, that one's pretty easy to memorize, right? Derivative of e to the x, e to the x. It is its own derivative. And that's all the derivatives that we have leading up to the test. So you should now have all the formulas you need leading up to next Tuesday's test. So let me just write off to the side here before I do the problem. So e to the x prime is e to the x, but that does mean the following. So be careful about this. I'll sneak this in. Now that we know this is the derivative, do not do this, which seems reasonable. It's not equal to / x e to the x minus 1. Okay, so watch out for that. Kind of logical. Some students say, oh yeah, I bring this down and then subtract 1. Okay, don't do that for e to the x. Okay, the derivative of e to the x is simply e to the x. And it has its own chain rule. And it might be combined with product rule, quotient rule, and all that stuff. Okay. Okay, so again, There it is. It's on my page 703. So that means don't go x, e to the x minus 1. If you see e to the x, the derivative e to the x. Okay. And then I'll show you how you would combine it with product rule, quotient rule, chain rule, and all that stuff also. Okay, and those are all the formulas again. So you should have everything you need for the test. Okay, so again, I'll show you. We have 11.2. I'll start it. 1 to 30, odd, 43, and 44. Okay. So I'll do some now, which will just make it easier next time. And for those of you who don't have the book and aren't getting it, so 11.2, page 706. So find the derivatives. Here we are. And let's see, I forgot. How far do we have to go up to? 30, I think it was. Yeah, there's 30. And then 43 and 44, a couple of word problems. 43 and 44. And there we go. Again, as usual, I'll go down all the evens, and your odds should be very much like it for the most part, I think. Okay. Let me check. Anybody have anything in the chat? No, guess not. Okay. Number 2, which will show you how to do number 1. Number 4 will show you how to do number 3, and so on. Find the derivatives. Y equals x squared minus 3e to the x. Y prime. Derivative of x squared is 2x. Okay. This is a constant times a function. Negative 3 times e to the x. So the derivative is the constant, negative 3, times the derivative of the function. The derivative of e to the x is itself, e to the x. So here it looks like you didn't do anything, but you actually did. You took the derivative. It just doesn't look like you did anything because the derivative of e to the x happens to be itself, e to the x. Okay, so that's my final answer right there. Okay. Number 4, f of x is 4 e to the x minus natural log of x. Right? So the derivative of 4 e to the x is 4 times the derivative of e to the x, but it's the same thing. So 4 e to the x minus, and we now know derivative of natural log of x is 1 over x. Okay, get the idea? So that's the way it works. And yeah, there's my focus job for that. Okay, so I'll do more on the other side. Just keep going until I feel like I've had enough. Number 6, h of x. Don't worry if it's not f of x, g of x, h of x, same thing. 750 e to the 0.04x. So this is a chain rule. Now, it doesn't look like it, but this exponent up here is considered the quote unquote inside function. Okay, 750 e to the inside function. So h prime of x, copy the 750, that's a constant multiplier. E to the 0.04x, and then by the chain rule times the derivative of 0.04x, which is 0.04. And then, yeah, 750 times 0.04 supposedly is 30. We'll confirm that with you real quickly here. 750 times, what was it? 0.04 times 0.04 is, oops, must have punched it in wrong. I think I hit divided by, I messed up. 750 times 0.04. Yeah, there we go, 30. Okay. So even though you have an exponential function, if it's not just x up here, the derivative isn't the same thing. You have to remember to multiply by the derivative of the exponent that's floating up there. Like over here, you have to multiply by 0.04x. Okay. How about number 8? E to the x squared minus 1. the derivative is not just e to the x squared minus 1. Oh, yes, you do have to write e to the x squared minus 1, but that's not all there is to it. Because x squared minus 1 is considered the inside function, I have to multiply by the derivative of x squared minus 1, which is 2x. Okay. And yeah, normally for the final answer, you put the 2x in front. So dy dx, 2x e to the x squared minus 1. That's the way it works. Okay, so one more time. If you have just e to the x, e to the x prime, e to the x. If you have e to something more complicated, the derivative is the same thing, but then times the derivative of whatever that exponent is. Okay, so like this one, right? You copy the e to the 0.04x, but then it's times 0.04. Here you copy the e to the x squared minus 1, but then it's times 2x, which is derivative of x squared minus 1. Chain rule. Okay. All right, number 10. Y equals 1 minus 2 e to the negative x cubed. Okay, well, the derivative of 1 is easy. It's 0, right? So just forget about it. Pretend it's not even there for now. Okay, the derivative of negative 2 e to the negative x cubed is negative 2 e to the negative x cubed. But that's not all. It's times the derivative of negative x cubed, which is negative 3x squared. Okay, and then if it's easy to multiply, you should, like this one. Negative 2 times negative 3 is 6. So final answer is 6x squared e to the negative x cubed. Okay. Okay, 12 is a little bit trickier. The problems at the end get much more tricky. Okay, y equals e to the radical x squared minus 9. So before I start that, keep in mind what square root means, right? Square root means raise something to the 1/2 power. So I'm going to write it as e to the x squared minus 9 to the 1/2. So here's a little sidebar here. Square root of 36, you can think of it as 36 to the 1/2 power, or 36 to the 0.5, which is 6. So if you raise something to the 1/2 power, it means square root. Okay, so let me demonstrate that for you. 36 exponent 0.5, 36 to the 0.5, 6. It's another way of saying square root. Okay, so raising something to the 1/2 power. So another side note, somebody a long time ago told me their square root button wasn't working. Okay, so I can't do square root on my calculator. Then I told them, okay, you can still do a square root. So the exponent key was still working. So raise it to the 1/2 power or the 0.5 power. That's the same thing as square root, right? So like the square root of 49 is 7. So I showed that person, just go 49 exponent 0.5, and there it is, 7. Okay, so your square root button was broken. Okay, you can still get square root by raising to the 0.5 power. Okay, all right. So now back to this problem. To find the derivative, y prime is same thing. First, I copy the same thing, e to the radical x squared minus 9. Now, times the derivative of the exponent. That's where I have to pretend it's x squared minus 9 to the 1/2 power. Okay, so here we go. 1/2 x squared minus 9 to the 1/2 minus 1. 1/2 minus 1 is negative 1/2. Right? So to the negative 1/2. And then by the chain root times the derivative of the inside, which is 2x. That 2 cancels that 2. Okay. Negative 1/2 exponent means square root in the bottom. That x is on top. So final answer, x, that x is the same as that x. The e stuff e to the radical x squared minus 9. And then in the denominator, because it's a negative exponent, square root of x squared minus 9, and leave it like that. Okay, and no, you don't get to cancel that with that, because that's part of an exponent. This is not part of an exponent, so we just have to leave it like that. Okay. So that's pretty much it for that one. Okay, 14. It looks complicated, but it really isn't. E cubed plus e to the ln x. Do you recall a way I can clean up e to the ln x? E and ln back to back cancel each other out. They're inverse functions. So this is the same thing as x. It's e cubed plus x. Furthermore, e cubed is a number. It's a constant. E is like 2.7. 2.7 times 2.7 times 2.7. It's a constant. Therefore, the derivative of this is simply 0 plus 1, 1. Okay, remember, e cubed is a constant. In fact, if you want to see it in a calculator, right? You do second function e, except I hit the wrong thing. Second function e cubed. It's about 20 something. But you don't really care its value. All you care about is its constant. 2.7 times 2.7 times 2.7 roughly. It's a number, therefore its derivative is 0. And furthermore, e to the ln x, just cancel it out, you just have x. So derivative of that is 0, derivative of that is 1. Final answer is 1. Okay. All right, I'm done with this paper. So let me do my focus job before I go to the next paper. The next problems are a little bit harder. I won't do too many more of them. And then we'll probably finish quite early, unless anybody has any questions. And I already showed you that. Okay. Okay, so where did I just leave off? 14, so 16. See how far I want to go here. Okay, similar theme. Y equals 2e to the radical x. So treat this as x to the 1/2 power, right? Square root of x, x to the 1/2. So the derivative is same thing, 2e to the radical x, temporarily ignore the red. Then by the chain root times the derivative of radical x, or x to the 1/2. So derivative of x to the 1/2 is 1/2 x to the negative 1/2. Okay. Again, very conveniently, the 2 cancels to 1/2, right? In red. And that's going to be a radical x on the bottom. X to the negative 1/2 means square root on the denominator. So e to the radical x over radical x. Okay. And once again, don't try to go any farther. Don't cancel these out. That's not allowed. So just leave it. Okay, 18. The original was written like this. 18. Y equals 2 over e to the 2x. And then they flipped it, e to the 2x over 2. Okay, now neither of those, I'm going to do the quotient root because there's a constant there. Okay, so again, if there's a constant on either the top or the bottom, avoid the quotient root. So how do I change it? This is a good example of how you do it for both of them, actually. 2 on top. Bring the e to the 2x up as 2e to the negative 2x. How about if I divide by 2, I sneak in a 1, write it as a coefficient of 1/2. 1/2 e to the 2x. Okay, so one more time. If you have a quotient, but either the top or the bottom is a constant, do not do the quotient root. Simplify it first. Constant on top, swing this guy up, so it becomes a negative exponent, 2e to the negative 2x. 2 is on the bottom. Treat it as a coefficient of 1/2 e to the 2x. And notice, I no longer have to do the quotient root here. I don't have to do the quotient root here either. All right. So here we go, y prime 2 e to the negative 2x times the derivative of negative 2x, which is negative 2. Plus 1/2 e to the 2x times the derivative of 2x, which is 2. Okay, 2 cancels a half. So 2 times negative 4 e to the negative 2x plus e to the 2x. Okay, and technically I should have kept going. My original problem started off with no negative exponents. So I could put this in a denominator, but so that would have ordinarily been the root, but there's one superseding root above that. And that other root is if you have e involved, you're allowed to leave the answer with a negative exponent. So there's an e, I can leave the answer with a negative exponent. So I don't have to go to, negative 4 over e to the 2x. Okay, if the base is e, you're automatically allowed to have a negative exponent. Okay. All right, then I was going to show you 20, and then that's basically it. And I've done quite a bit of the next section, and it's barely going to be 5:30. So I'll be done in a few minutes, folks, 2 or 3 minutes. If anybody wants to ask any questions, you may, but if not, then we're finished. Okay. And look at how much we've progressed. This was originally the game plan. I'm about to finish question 20, which means next time I only have to do the ones at the end, although they're a little bit harder. They're definitely harder. And then I guess a couple of word problems here, but we'll see how it goes. So 20 is the first of the harder word problems. Harder problems that we have. All right, P equals 4q e to the q cubed, q to the third power. Kind of hard to say q cubed, I guess. Sounds like the same thing. Okay, product root, first function, second function. So yeah, why are these problems at the end harder? They're going to be product root, quotient root, and chain root all. So I'll save it for next time. So even though we don't have that many problems left, they are harder problems. So again, that's another good reason that I started sneaking in some of 11.2. All right, so product root, first function, copy it, 4q times the derivative of the second. Derivative of e to the q cubed, e to the q cubed, times the derivative of q cubed, 3q squared. Plus second function, e to the q cubed, times the derivative of the first, derivative of 4q, 4. And that's it. And just a little bit of cleanup. Let's see, 4 times 3 is 12. Q times 2 squared is q cubed. And that one just put the 4 in front. So final answer, 12q cubed, 12q to the third power, e to the q cubed plus 4e to the q cubed. And that's about it. Okay, so I was going to stop there so I can save the rest for next time. So it should not be that bad next time, although they're harder problems. I think I only have about 7 or 8 of them. Okay, so next time, if you want to come in with questions and answers in preparation for the test next Tuesday, you can. So formal lecture next time will not be that long. Knock off the rest of 11.2, question and answer, and then quiz. Okay, and then next Tuesday, question and answer, and then we go straight to the test. All right. And there we go. So let me check the chat. Okay, nothing extra in the chat. Okay, any other questions, please? Otherwise, we're done for the day. So anybody else? Okay, yeah, anybody who joined late, put your name in the chat now. I do see Caitlin got you, Omar, Adriana, I got you. Anybody else who joined late, please put it in the chat. Okay, and any other questions? Otherwise, that's it. Okay, hearing nothing and seeing nothing, that'll be it for tonight. All right, so that's it for tonight, folks. Have a good night, and we'll see you next time. Okay, bye, everybody.
Thank you.
Thank you.
Thank you.
And then I got you.